In this video, we're going to talk about creating one-to-one equations to solve. All right, so we already know we can solve exponential equations when there's a single exponential on both sides, so there's one exponential, and they have the same base. So this process of kind of eliminating the exponents only works when they're only one on each side and it's the same base. So right here, this is a problem. We can't just say x plus 3 is equal to 5x minus 2 because 4 and 2 are different numbers. So we have to somehow change them both to be about the same number. And generally, the strategy is going to be to make it based on the smaller number. So we want to rewrite 4 to look like 2, and 4 is 2 squared. So all I did was write that 4 is 2 squared, right? 2 times 2. I still can't do anything quite yet because I have all this extra stuff going on the left, but we have an exponent rule that when you have this double exponent, you multiply. All right, so that's just multiplying those exponents. And if I remember to distribute, I get 2x plus 6. So now I took this equation where I have two different bases. Now this one has the same base. And we know once we have the same base, we can kind of eliminate them and just set those exponents equal to each other. And now after all this work, now I have a much simpler linear equation to solve. I'm going to move the x's to one side, move the numbers to the other side, and then divide by 3 to get my final answer. All right, so this is creating this equation where eventually I can get rid of the exponential part. All right, we're in the same situation here. We have a bunch of extra stuff, but we see we have these x's in the exponent, so we need to somehow get all the same bases. Okay, generally, we're going to look at the smallest numbers. So we have 27, 3, and 9. We want to write everything as base 3. Well, 27 is 3 cubed. That's base 3. 9 is 3 squared. Again, you're thinking in terms of exponents. And then on the left-hand side, we don't have a single exponential, but we have a rule that when we combine exponentials like this, we add the exponents. On the right-hand side, just like our last example, we multiply those two exponents. And we simplify the exponents by distributing and adding. And now we finally have base 3 on both sides. We can eliminate them, get the x's on one side, the numbers on the other, and divide. So at the very end of it, we get x equals 0 as our final answer. That's just a basic strategy for creating an equation that looks like this, where we can finally get rid of those exponential parts.